Stoichiometry uses molar ratios from a balanced equation to predict the amount of products a reaction will produce. It can also tell you how much of each reactant is needed for a desired amount of product. A balanced equation is very similar to a recipe if you want to know how much is being made or coming out. Here we have a turkey sandwich recipe. 2 slices of bread plus 1 slice of turkey is going to equal 1 turkey sandwich. So if we have 10 slices of bread and excess turkey, anytime we see excess, that's going to mean that we have extra. So how many turkey sandwiches can we make? So the first thing we're going to do is, just like we've done before, is if it says 10 slices of bread, that's what we're going to start with. Whatever unit we're starting with has to go on the bottom. And what we're converting to is going to go on top. So slices of bread on bottom and sandwiches on top. Now we need to find our ratio. From our equation up here, it says that we need 2 slices of bread for every 1 sandwich. And now we can solve. Remember that we multiplied across and divided the bottom. So 10 times 1 divided by 2 gives us 5 sandwiches. You could have probably solved this problem without setting up this chart, but you need to set up this chart for all of the problems that you'll be solving. So for these practice ones, make sure you're setting up your dimensional analysis table, regardless of if you can solve it without it. For number 2, it says that we have 6 slices of turkey. So that's what we're going to start with, 6 turkey. And excess bread. Remember, excess is extra. So we're trying to convert our 6 slices of turkey to sandwiches. So if we have turkey on top, we're going to have turkey on bottom. And we're converting to sandwiches. And now our ratio. We have 1 slice of turkey for every 1 sandwich. Multiplying and dividing across, we get 6 sandwiches. Go ahead and pause the video and try the next one on your own. Restart when you have your answer. On number 3, it says that we want to make 15 turkey sandwiches. So how many slices of bread should we start with? Your work should have looked like so. 15 sandwiches for every 1 sandwich, 2 slices of bread, giving you 30 slices of bread needed. Go ahead and pause the video and try number 4 on your own, and let's see if you can figure it out. For this problem, you needed to set it up twice. 14 slices of bread to sandwiches, and then 5 slices of turkey to sandwiches. So now the answer is, can we make 7 sandwiches, 5 sandwiches, 2 sandwiches, or 12 sandwiches? If you said 5 sandwiches, you are correct, because you can only make as many sandwiches until the turkey runs out. When the turkey runs out, I can't make any more sandwiches according to my recipe. So always box in the smaller answer, you don't add them together. So just like our recipe was our equation, a chemical reaction tells you that, in this case, 1 molecule of nitrogen combines with 3 molecules of hydrogen to produce 2 molecules of ammonia. The number of molecules also refers to the number of moles. So you can compare the number of moles of a compound that go in with the number of moles of a compound that is produced. So according to the reaction above, 1 mole of nitrogen would react with 3 moles of hydrogen to produce 2 moles of ammonia. A molar ratio or mole ratio uses the coefficients in a balanced equation, and it's a way of comparing the number of moles of one substance to another in a chemical reaction. So we just picked 2 things, nitrogen and hydrogen, or nitrogen and ammonia, and we look at the numbers in front. So if we looked at nitrogen and hydrogen, we have 1 mole of nitrogen that would react with 3 moles of hydrogen. So this would be our mole ratio. 1 mole nitrogen, 3 moles hydrogen. Our mole ratio of hydrogen to ammonia would be 3 moles hydrogen for every 2 moles ammonia. And finally, we could also compare nitrogen and ammonia. So 1 mole of nitrogen for every 2 moles of ammonia. Here, we're going to use those mole ratios. It says how many moles of ammonia, NH3, are produced when 0.6 moles of nitrogen react with excess hydrogen. This is exactly like our balanced equation with our sandwich. We just have a chemical equation now up here. So just as before, we have 0.6 moles of nitrogen, and whatever goes on top is going to go in the bottom corner, and what we're converting to goes on top. Always worry about your units before worrying about any numbers. Nitrogen doesn't have a coefficient, so that's a 1. And then NH3 has a 2 in front of it. So multiplying, I get my answer to be 1.2 NH3. On A, it says, what are the 6 molar ratios for the reaction above? I could have had 6 molar ratios here. I would have just had the reciprocals of these. So 3 moles hydrogen over 1 mole nitrogen, and so on. So if you want, for A, you can just do the 3 molar ratios. I'm going to pause the video and try A on your own. So for my first one, I can do aluminum and oxygen. 4 moles aluminum for every 3 moles oxygen. Then I can do aluminum and aluminum oxide. 4 moles to 2 moles. I could reduce this down to 2 and 1, but that's just one place that I could make a mistake. So you don't need to reduce down your mole ratios. And then I can do oxygen and aluminum oxide. So those are my 3 molar ratios. If you wanted to write all 6, then you can write the reciprocals of those. Go ahead and try B. Restart the video when you have an answer to B. So first you should have written what they gave you with the units. And then put your moles of aluminum oxide and moles of aluminum on top. So we're using this middle mole ratio. So we have 4 moles should go with aluminum from our balanced equation. And with aluminum oxide we should have 2. Multiplying and dividing in 2 sig figs, since that's what we started with, our answer should be 7.4. I'm going to pause the video and try this one on your own. Restart when you have your answer. So we start with 2.4 moles sodium hydroxide. Worry about our unit on bottom, moles sodium hydroxide, and moles of what we're looking for on top. Mole to mole, we got to look at our balanced equation. 3 goes with sodium hydroxide, and 1 goes with sodium phosphate. Multiply and divide, and we get an answer of 0.8 moles. So if you're given anything but moles, you have to convert to moles. So if they give you grams or liters or molecules, we convert that to moles. Once you have moles, then you use your mole to mole ratio, just like we were doing. And then if they want their answer in something other than moles, we're going to convert to that unit. So in reality, you could have 3 steps. For every time you are either given or converting to moles, you take off a step. If you don't remember your mole conversions, you may want to write those down at this point. Remember that 1 mole is equal to so many grams. That's our molar mass, and we get that from the periodic table. That's going to be different for each substance that we have. 1 mole can equal 22.4 liters, and 1 mole is equal to 6.02 times 10 to the 23rd particles. Those particles can be atoms, molecules, ions, whatever you're dealing with. All right, so in A, it says, how many moles of ammonia are produced when 16 grams of nitrogen react with excess hydrogen? Remember, excess hydrogen is just extra. So I'm going to start with what they gave me. But they gave me grams, so I have to convert grams to moles because that was the first step. My molar mass of nitrogen is 28.02 grams. And then I can convert grams to moles. It's always 1 mole equals so many grams. The only time a number other than 1 is going to go with moles possibly is when it's mole over mole. Now I have moles of nitrogen, so I have to have moles of nitrogen on bottom. And I'm converting to ammonia, so I'm going to have moles of ammonia on top. Notice moles over moles, so nitrogen gets a 1, and NH3 gets a 2. So my grams nitrogen cancel out with grams nitrogen. Moles nitrogen cancel out with moles nitrogen. Right now I have moles NH3. And I want moles NH3, so I'm done. Multiplying and dividing, I get 1.1 moles. Notice that we have moles and grams, they're the same substance. The only time I can have different substances is when it's moles over moles. Let's look at the next one. We're starting with 18 grams of hydrogen. If we have 18 grams of hydrogen, we're going to have grams hydrogen on bottom. And hydrogen is diatomic. We can also tell that from the balanced equation. Its molar mass is 2.016. First step is convert grams to what we're looking. Convert grams to moles. And it's always 1 mole equals so many grams. I have moles hydrogen, which means I need moles hydrogen on bottom. And I'm converting to moles of nitrogen. According to my balanced equation, 3 moles hydrogen for every 1 mole of hydrogen. But in this problem it says how many grams of nitrogen. So I'm not done. I have moles nitrogen, 2 grams of nitrogen. And again, that's 1 mole for 28.02 grams. 18 times 3 times 28.02 divided by 2.016 gives you 83 grams. You could have also divided 18 by 2.016, then times 3, then times 28.02. Go ahead and pause the video and try A on your own. Restart when you have A done. So we started with 30 grams of chlorine, which means we need grams of chlorine on the bottom, and we're going to convert that to moles of chlorine. First step, convert what they give you to moles. And this time I'm going to go ahead and set up all of my equation, and then I can go back and add to that. I have moles chlorine, so then I'm going to have moles chlorine on bottom, and I'm trying to get to grams sodium chloride. So I need moles sodium chloride on top. But I don't want moles as my final answer, so I need one more step. Moles has to go on bottom, and I'm trying to get to grams. So notice my units are always diagonal from each other. I have grams, so the molar mass of chlorine is 70.9, and that's for every 1 mole. My molar mass of NaCl is 58.44, And again, that's for every 1 mole. Mole over mole, I'm looking at my balanced equation. 2 goes with NaCl, and 1 goes with chlorine. So your final answer should have been 49 grams NaCl. Go ahead and pause the video and try B on your own. Restart when you have the answer. So they gave you 48 grams sodium. So we're going to have to convert our grams to moles. And then moles of sodium to moles of chlorine. But we don't want moles of chlorine. We want liters of chlorine. Now we can go fill in everything. 22.99 grams is the molar mass of 1 mole of sodium. For every 1 mole of chlorine, we have 22.4 liters, because 1 mole is always 22.4 for a gas. And now for our ratio, we have 2 moles of sodium for every 1 mole of chlorine. Multiplying and dividing, you should get 23 liters of chlorine as your final answer. Go ahead and pause the video and try this last one on your own. Restart when you have your answer. So just as before, we start with 3.45 times 10 to the 24th molecules, and that's molecules of chlorine. So I'm going to have molecules chlorine on bottom. And that means I'm going to have to convert it to moles chlorine. Moles chlorine on bottom. Converting that to moles NaCl. And then moles NaCl to moles of, or to molecules of NaCl. We have 6.02 times 10 to the 23rd goes with molecules. 1 always goes with moles when it's with molecules, liters, or grams. And 2 moles of NaCl for every 1 mole of chlorine. Multiplying and dividing, you should get 6.90 times 10 to the 24th molecules of NaCl.